Stanford University.
So the purpose of these short surveys is to ask you, the community, everybody gathered here, how you feel about certain things. And this one is about train scheduling. So why bother with train scheduling? What's the problem that it's trying to solve? Well, simply, we've got too much data needed by too many tasks or jobs, and not enough time to process them. So train scheduling is trying to give us more efficient I/O, because bandwidth is expensive, especially bandwidth to disk. IOPS, meaning I/O transactions to those disks, are also expensive. Disks are terrible when you try to seek all over the place. And our data is big, so it doesn't fit in cache. So in this context, we're going to define train scheduling as scheduling multiple jobs that require the same data file or chunk simultaneously, so that the scan over this chunk can be performed once and fed to everybody who cares. Sometimes people also call this convoy scheduling or cooperative or shared scanning. So what do we mean by train scheduling? Well, we share the bandwidth, like we said in the definition. We've got a bunch of jobs coming in. Instead of letting them each issue their own I/O requests, we issue only one set of I/O requests, one scan over a file, and we feed it to everyone. This minimizes the number of I/O transactions we're doing to our underlying subsystem, and it means that if we want to add more jobs that need the same data file, it doesn't really cost us any extra I/O, which is pretty nice. So you can think about it as if we're all going to the same places, shouldn't we share a train, right? But train scheduling is not as widespread as perhaps it should be. Maybe because we're incurring too much latency. Because maybe you miss the train and you have to wait until it comes back around. Or maybe it's too complex. Train scheduling means that instead of taking each individual independent request and letting it make all of its own I/O requests, we're getting a bunch in, having a look and seeing, well, what do you guys need? And saying, OK, we'll schedule you together because you need the same thing. And another problem or issue, you might think, well, maybe it's not needed. Maybe my idea of too much data, maybe it really does fit in the cache. So maybe we don't even need to bother implementing this. So this is a survey, so it's all about what you guys think. What do you think are the most important issues to consider before doing train scheduling? Is anybody in this group doing train scheduling? And if so, in what context? So if you would raise your hand, some KT will come down, and let's hear what you think.
So in the Teradata database, the train scheduling, which we call synchronization scan, is built in. And one important thing I think about the implementation is you don't actually have to gather all the jobs that are scanning a table. Okay. Anybody can hop on at any time, and if you hop on halfway through, you get half of a shared scan, and then you go back up to the top, and so on. So the latency isn't really an issue if you do it in that way.
Okay. Are there any other issues that I didn't mention, or do you agree with the other issues? Like, was it a complex thing to implement? Was it worth doing?
It was definitely worth doing because there's a small number of in most data warehouses, there's a small number of tables that get scanned over and over and over again. Okay. Right? And each of those queries applies different where clause predicates and so on. Right. But that gets applied after you've already done the I/O and brought the block in and so on, so you get the benefit. Right. If your query is looking at a very small subset of the data, obviously, and you're sort of doing partition elimination, then of course there are differences. And when you get into columnar databases and people want different columns, then it starts to get a little bit more complex.
Okay. Okay. So, Mike?
Hi. So yeah, I think IOPS bottleneck is a big problem that almost everybody is trying to solve in different ways, right? So one option that you mentioned is train scheduling for like batch and those kind of systems. On the other hand, even for big data systems, sometimes or many cases, many times, the actual hot set of data might not be that big maybe, although it's a very big warehouse. So are there other ways we can solve the same problem by maybe, especially because memory is becoming cheaper? Is there a way to like front end all these big data systems with larger amounts of cache and handle frequently accessed tables that way?
Or are you asking? This is a survey. Maybe the guy from Teradata wants to answer.
Certainly, memory is getting cheaper and bigger, and so you certainly do bring the hot data into memory. But if you look at, you heard presentations this morning, if you look at the industry in general, the data is growing faster, the memory is getting cheaper, right? So there's a lot, every 10 years we go into this thing, put everything in memory. And in 3 years, everything in a fit in memory will be done performance-wise and so on. In 3 years, the databases we're building today will fit in memory. They won't be the same size, right? So yes, you have to use memory for caching, but I still think this technique is useful for the very large data.
So I think you need to make a big distinction between row store warehouses and column store warehouses. This is a great idea for row store warehouses, but for column store warehouses, my experience is that the K users that you would put on the same train are asking for different columns, and therefore putting them on the same train does nothing for you because they're doing independent reads. So I think in a row store, this is a great idea, such as Teradata is selling. In a column store, it's probably of very little value.
Okay. Anyone else?
So as a preparation for our big data challenge, we did some exercises with how the kernel parameters for basically IO scheduler affect the performance.
Okay.
If anybody is interested, I have the 2 cases for SSDs and hard drives in RAID 0 setups. I'm glad to share them.
Great.
Anyone else?
Anyone?
Okay. All right, good.
Okay.
Thank you very much. Oh, there's one more.
Just a quick comment on why the trainer scheduling would not work in the columnar. Just want to understand a little bit better, because if there are a bunch of queries that are going against column A, then probably the same strategy would apply, that if you'd bundle those together, then you are just reading that column once as opposed to 3 times or 5 times. So just want to get a little bit of clarification.
Right. I guess Mike wanted to answer that.
Well, my experience is that in a typical data warehouse, the fact table has 100 columns, and the next query, reads 3 random columns out of 100. And the chances of there being hot columns are just not that high. That's just been my experience. But you're absolutely right if there are hot columns.
Okay.
Okay, all right. Thank you very much.
For more, please visit us at stanford.edu.